Android SDK, the Android system consists of the Android SDK, the Java JDK, and your development platform. You can develop everything using command line tools. I don't know why you would. Don't do that, I guess, but you could compile it from hand using their like ADB tools. And we'll go over like some of the Android like command line tools later too. Not today, but in another workshop we'll probably do that. So yeah. So going back to what I was originally saying is you need to download Android Studio. Hard to. And how do I put it up here? There we go. So go to this link.
I think if you Google Android Studio download, it's like the first thing that comes up.
Yeah, it should be. Hopefully everyone in this room knows how to Google as well. I'm gonna assume that.
It's just
Yeah, it's gonna save
and
a lot of
also
headaches. If this loads. So while that's loading, I guess I'll go into the little spiel of like why Android. So hey look, there it is. So yeah, we'll do it while you're downloading it. So click on the download Android Studio. Now this is like too elementary, let me know, but there are some things, blah blah. I've read download Android Studio for Linux and accept it. And let's do a thing. When you install Android Studio fresh, there's two things that you need. One Android Studio takes care of, one Android Studio doesn't. The first thing you need is the Java JDK. It needs at least Java 7.
No, I think it needs just 6.
Okay, it needs at least Java 6. Now, for those who aren't aware, there's two types of Java installs. There's the JRE, which is a Java runtime environment, and the JDK, which is the Java development kit. The JDK contains the tools that let you compile Java code down to Java bytecode. Android requires this. Now, for Windows users, it's pretty painless to install. For those using Linux, like at least Ubuntu, I don't know about other distros, it usually doesn't find your JDK, so we can go over how to fix that if we come up to that.
I found a shell script that you can install before you
Yeah, I mean, yeah, that's also possible. So that's a little bit about that.
If you're on Mac, it should update Java for you automatically.
So this is downloading now. This is the first time we're doing a workshop, by the way, so I apologize for any hiccups or like we seem like we don't know what we're doing, because we totally don't. We're making this up as we go, for the most part. Okay, so yeah, unpack it, and then launch Studio. So the second thing, like I mentioned, there's two parts. You also need the Android SDK. Now, Android Studio provides an SDK manager which downloads all of this for you. That takes a little bit of time. Today, just download, I guess I'll have, is anyone like not finished downloading it? Is anyone actually downloading it, or are you just watching me go through the slides?
Just take me all later.
That would probably be me. That'd probably be all of UV, and then our wonderful infrastructure that we have for internet. Yeah, or, oh wait, no, I just gotta click this thing. I don't know how to PowerPoint. Okay. Let's see, so I'm just gonna go through the install like instructions, and then while everyone's like installing / downloading, we'll like move from there. So you'll get this window when you first go to install it. Click X. Click standard. If you're feeling like industrious or whatever, you can go into custom, but I just recommend doing standard for now. And just accept this. Basically, this downloads the Lollipop SDK. So for those who, once again, aren't too aware of like how Android is, there's different API levels, which is basically they're different OS releases.
And we're currently on 21.
Yeah, so 21 is the latest. I'll go over like why that matters, but basically certain phones are incompatible with certain versions. We'll be just focusing on pretty much, it's always going to be backward compatible. I just want to focus on 21 for like today to get everyone like at the ground level, and then we can go through installing different ones. So click accept and then finish.
You can set different target ones too, so like when you're actually running your code on a virtual machine or on your phone, it'll compile for like Android 4.3 or 4.4 or whatever. So.
Yeah, and we'll go over fragmentation and what fragmentation means and stuff in a couple of slides. Is everyone at this point? Is everyone like getting to this point? So I'm gonna leave it to someone to like tell me when they get to this point and where it's like done downloading. So while that's going on and we kind of have some dead time, I just want to talk about like why I'm doing Android and why I'm running this workshop, I guess. So one of the cool things, first off, about Android is that it's very accessible. You don't need any special equipment to write for it. So the problem with iOS, at least in my opinion, is that it relies on having an actual Mac, and I'm kind of a poor college student and can't afford a Mac, so that's a little bit of a cost barrier there. Nice thing about Android is, like I said, you don't need a phone. You can use the Android AVD, which is a virtual Android device, which we'll be using today, just to start. It's a little terrible, I apologize,
If
but
you want to use your phone, we can show you that.
yeah. So like we'll go over like using your phone after at the end of this, but just to make sure everyone's on the same page, we'll be using the emulator. So not only do you not need a device, but there's also very low cost into the Android marketplace. I think it's only $25 to like make a Google account or something on Google Play. Someone correct me. Whereas it's $100 a year for iOS. So the cost a little bit lower upfront wise. And then the other part is just mobile is a fun platform to develop for, especially because you have so much different things you can use. So like a computer, you're kind of limited to like you can use internet and like you can display stuff and get like some basic input. Whereas phones, you get accelerometers and gyroscopes and like temperature sensors. I don't know why someone needs that on their phone, but whatever.
Well, you do more stuff on it.
Yeah. Or like an IR blaster if you have an S5, another like wonderful sensor you can do something with for some reason. So that's like some of the reasons why I like developing for mobile. So yeah.
I really like it because Google gives you so much to work with. If you guys haven't noticed, like there's maps, there's some other examples
Ads. It makes it very easy to put ads in your app. So that's pretty good.
when we're like I guess going through the API, there's so much there that you guys can use. Another reason I love Android is because how many of you guys are in your second semester, like 116 level? You guys know all that you need to know to start making Android apps. That's what Google really wants you guys to do is they want people to develop. So
Yeah. Going on from that, as long as you've taken 115, and I posted on the Facebook list, on the Facebook group like page for this particular event, the things that you should know. As long as you have like a basic 115 knowledge and you kind of know how to program in Java, you pretty much have everything you need to know for Android, barring some like interesting parts of Android, I guess you'd say. The hard part of Android isn't really the programming; it's just understanding how the framework is built, which presents some interesting challenges, in my opinion. Is anyone up to this part? Is anyone even close to this part?
I'm not, so we'll take it.
Um,
One big point.
would it be productive if I went through the entire presentation, or like you guys
We
just
guys
want
can cut you guys off.
to like have an open discussion? Like, what would work for you guys for this case? Probably should have like had everyone download this beforehand. How many how many people would have actually came with it downloaded? Honestly, wow. Way better than I would expect.
Can I ask everyone a question?
Yeah.
Question for everyone. This is just you guys can shout out or raise your hand or whatever you want to do. So why do you guys want to learn how to program Android?
Ooh, my team.
Why not?
Thanks. Anyone else? Or just
So, so you could go with technology.
Oh man, isn't that the dream?
yeah.
Resume builder?
Resume Builder's a great one.
A hobby? I just make something which makes it easier. You have some, you know you want to do something, you just can't find it, so just make it easy.
Yeah, absolutely. One of the things I really love having access to is GPS. I think that GPS is an interesting sensor to be able to like access and get someone's, especially so with Android because you always have access to like yeah. So let's backtrack. Because you always have internet access on Android, it gives you access to any level of APIs. Who here knows what an API is? Alright, so an API is just some application interface. So like Google Maps has a developer API, which is basically like how do you access? Question or?
Yeah, I'm not able to install the MX yet. They're asking for the JVM.
Okay. Does anyone else have any problems with JDK?
All right. That we
comes down to the fact that your path is a little screwed up to Android. Who here does knows what a path is? Who here is using Linux to do all of this? Windows? Mac? Alright. Mac people should be fine. I don't think it's been a problem for Macs. But let's go first for Mac and Windows people. And if you install the clips and you've used the clips, this should hopefully already be done. If not, wow, the internet is pretty slow.
You're on kind of the edge.
You'd think like a conference room would have like wonderful slamming internet. Is there like
I've connected to options.
it totally is not alright, maybe I should scroll it. Okay. So for those on Windows and Mac, not Linux. Linux's process might be a little bit different depending on which distribution you're using. For those who aren't using Ubuntu and are having problems with Linux, I'm sorry I can't help you. You'll have to Google it.
I have it on close servers that work before, and I just use it for today and just download it. Is it like way different?
Yeah, it's not. The interface is going to be different, but the program will be the same. If you want to download the ADT, definitely would work. You'll still have to download the plugin and like the ID for it though. I'm sorry, I should have accounted for the internet speeds being atrocious, but for some reason it's like, oh yeah, UV. Like we should have like megabit fast internet.
Yeah, this one's are doing that too.
Don't.
That's what you keep doing, then your downloads are
Alright, so because this is not going to load, Google the Java JDK. For those who are on Linux and having a problem, if you're on Ubuntu, look up how to install the Oracle JDK. You then need to set your path if you're once again on
We
Ubuntu.
need to post that later.
Yeah,
Same thing as when you find your because I believe they had the same one.
yeah, so like you need this thing. So this guy is what you want for those on Windows, Linux, and Mac. For Linux, I suggest Now, here's the part where there's something worth talking about. So, we come to the point where like you have to pick your minimum SDK. Now, a minimum SDK is the lowest level of OS version that your app will run on. If you choose SDK 21, which is Lollipop, it's the newest version, it's Android 5.0. It will run on about 0% of devices. Not great for market share if you're trying to make money. If you choose, what is it, Ice Cream Sandwich 4.0, you're targeting 87.9%. And this brings us to the topic of fragmentation. So, each SDK and API level, kind of the same thing, each level gives you more and newer Android features at the cost of the fact that because Android leaves it up to different manufacturers to make phones, it's also manufacturers' jobs to provide updates to those. And well, when you have like 100 phones every year, guess what? You don't tend to update them often at all. And this is why we get like only 24% can run on KitKat, which is like kind of bad. Android's trying to address this. This is something you need to be aware of. When you're developing an Android app, if your goal is to release it on the Android marketplace, decide what the maximum number of features you need are and which API they target. If you don't need something from Android 5.0, it's probably a good idea not to target Android 5.0, as no one will be able to download your app. Now, the Google Play Store takes care of this automatically. So you might have noticed when you search for apps that if you're on like searching for them on a tablet or a phone, you get different results. And that's because the Google Play Store looks at your app and says, okay, which devices do you support? If someone's searching for your app on an unsupported device, they don't bother showing it. So there's no point in like showing a user what they can't download, right? That's not great for other app developers. So be aware that this problem of fragmentation exists. When people talk about Android fragmentation, this is what they're kind of talking about. The idea that you have a lot of different legacy devices that can only run like certain versions of the SDK. As for what each API level gives you, you'll just kind of have to read through Android's documentation, as I couldn't possibly tell you what each one is. There's a lot. Generally, you probably can get away with doing 4.0, which targets the like 87.9%. It's a pretty good market share to hit. Any questions on like fragmentation, SDKs, APIs? A lot of like buzzwords going out there. Sure.
Since Android Studio is quite developed, so which of the binaries or Windows application do I need to install Android Studio? And if I use Android Studio Plus, it's very heavy because I support binary.
Have you been using the newest version? Like, um, I haven't had a problem with it on like on Linux or Windows. So like,
I've only used it on Ubuntu, so I couldn't tell you what's better.
it has Android Studio has gotten better, and they've been releasing frequent updates. There's kind of not a choice. I don't know if that really answers your question. Um, any other questions? Okay, cool. So basically going through, when you start your first activity, what we're going to deal with, as if everyone was doing this along with us, would make a blank activity. I'll go over a little bit like what activities are. Basically, it sets up your app to have like a basic starting ground. This way you don't have to write a lot of boilerplate code. Alright, so a little bit about like what the Android interface looks like. For those who've used Eclipse, this should be kind of like similar. It should be for those who use like the IntelliJ Java IDE, it should be very similar. So Android Studio is built on IntelliJ, which is just another IDE to develop in. Basically, we have a run button, which just launches your app. Should be pretty basic there. The SDK manager is what allows you to download different SDKs. So
like Google services.
yeah, so like you can download like their ad service if you want to monetize your app, or like their Play Store service if you want to actually like release your app. Or if you're targeting a particular SDK, instead of like Android Studio downloading all 21 SDKs, which is probably a lot of like hard drive space to take up, it just downloads whichever ones you tell it to. You can also get like source code, documentations, code examples. and like I encourage everyone to explore the SDK manager. From there, there's also the AVD manager. An AVD is an Android virtual device. This allows you to basically make an Android phone with any like spec that you want. So you can give it as much memory or as little memory, whatever screen size you want, whatever kind of like.
Phone brands too.
Yeah.
Nicest phones.
So it's nice if you don't own say a tablet, but you want to see how your app looks on a tablet, or if you need to test your app on like multiple phones at one time or something. Yes.
Did you say how long support to make an app on specific devices versus all devices?
I mean,
Or
Android
was
didn't
that
really.
just an
I'm not 100% sure.
Yeah.
Like, so Android gives you a lot of resources to make. So because so there are some downsides to Android. I guess it's worth talking about. So the upside of iOS is that there's a very small number of devices, right? Like they're very Apple's the only one who releases them. You're pretty much guaranteed that everyone either has like a pretty similar looking device, like screen wise. Like either it's a tablet and there's only like a couple sizes. With Android, you have any number of devices, sizes, button configurations. Some have keyboards, some don't. Like, kind of like a huge host of them. To mitigate having to write like 200 different versions of code, which hopefully we all know is horrible. And like, if you're writing 200 like if statements to handle these cases, probably a bad way of doing it. So instead, they give you some resources basically to they take care of the coding for different ones, and you can write like UI code that targets specific sizes, etc. Which we can also talk about either today or next workshop. We'll go over more on UIs. Now, Android Studio, there's two ways of like designing your app. We're gonna primarily focus on the coding aspect. So you can all see though, however, that you can actually drag and drop components. It's not a bad way to like mock up a design. The downside is for anyone who's worked with say auto-generated any code, it's ugly and tends to look messy and like has a ton of like hard-coded like values in there. So suggestion wise, like maybe mock it up like this if you need to do like a quick thing, but we'll be focusing on the XML side. If you click on the XML tab, if you were doing this long, you'd see that like all of your UI is done in XML. Now, for those who don't know, XML is just a type of markup language, kind of like HTML you can think of. It's like very similar. It's used for like transferring data, like across the internet for like building hierarchies of stuff. It's nice. So how many people here have used Swing? Wow. Okay, very few. How many people have like used like HTML? Better. All right. So you're gonna find that design in Android UI is very similar to using HTML. There's two ways you can make an Android UI. So you can either code it in XML, or you can actually instantiate all of the view objects, which we'll also talk about like in a couple slides. So you can like instantiate all the components and like build it pragmatically through code. I suggest not doing that, as it couples your UI with your logic, which, for those of you who kind of know some design practices, not the greatest thing to do either. So this gives you a nice way of decoupling UI code from logic code. Alright, so the actual interesting parts. So Android has like this idea of views and view groups. So view groups are containers. They hold things like layouts. For instance, like linear layout, relative layout. These are all like different ways of aligning your code or aligning your UI elements. And then it has views. Views are the actual content. So by combining view groups and views, you can get nice looking UIs that are like very structured, easy to hopefully manipulate, etc. You can put view groups into other view groups. So you can have like a linear layout that aligns everything vertically, and then you can have like multiple linear layouts inside of that that aligns everything horizontally, etc. The actual views is like a text view per se. So if we go back, and you can see, I know it's not very large. We can see, yeah. So you can see how it says "Hello World." So that's a view. It shows content to the user, and those you can like manipulate and like show content, etc. All right. So going from there. which brings us to like the actual coding part, which is where Android gets a little bit interesting and can be kind of cumbersome to work with. So Android apps consist of what's called activities. So on earlier slides, you probably saw where it said like you make a blank activity. So what is that? Um, how many people here know what the main method is for Java or the main function in C? Please, hopefully everyone raises their hand. If you don't, this might be a little too much. Basically, Android has no main method per se, at least not one that you see. So the operating system itself kind of takes care of main for you. And instead, all of your code is encapsulated in what's called an activity. This activity is just kind of uh, it's a class that extends another class and implements an interface. Well, not directly. It implements basically abstract methods, which will be on the next slide. That kind of determines how your app runs. And I'll go through those now. So there's going to be, and it would be better if everyone can actually see the code on the screen, but there's a few abstract methods that the activity class has that it's your job to implement. So these are, first off, who knows what a callback is? No, okay. So a callback is just a function, or like a function in an object that you can give to another class. So say like you have class, okay, actually let's go with this. How many people here knows what an action listener is?
So you guys know what a callback is.
Okay.
It's just a different name.
Yeah, so an action listener is an example of a callback. So you like implement your action listener, right? You have like your action performed. Does anyone want me to like make this on the board that I'll put you in? No one? Alright, someone just scream at me if something's beneficial or not to you. Basically a callback, you give your function or your object of the function, so let's say an action listener, it has like action performed, right? So you give that object to another object. So let's say your button. Now when your button gets clicked, it calls the action performed callback. And this kind of lets your program, it gives your program a chance to run. Makes sense to everybody? Any have questions on that? Or like callbacks? Okay. So,
I completely
yeah, absolutely.
Alright, so when you extend activity and whatever your main activity is, whatever you call it when you start up, you should be able to override all of these methods and say like on create, you want to set your content view. So every activity is associated with your backend and then your view. So you normally, I think it's set content view.
Yeah.
Whatever your layout is. But you can override all these methods to do what you want. So let's say you're dealing with some kind of data in your app. And I don't think on destroy, but like if you hit the home button on your phone, it'll call on pause. So when that pauses, you may want to like save your data or whatever you want to do with it. So you have complete control over what these methods do.
Yeah, and it's up to you to implement your code in the right positions. And this is very important. And I have actually have like a picture on 2 slides from now that'll go through what happens through your app. So for those of you who've been programming like say in Java, you're probably used to like, okay, your program goes into main, it does some stuff, and then it exits when the user either closes it out or you just finish your work. Android apps are a little bit different, right? Because like you can't have multiple windows open on the phone. So what do? The solution to that is that you put apps in the background. So say a user's using your app, they get a phone call, well now your app's hidden. Or say they press the like home button. Now your app is like in the background. And because phones, you don't want to use like a lot of battery power, so this is some of the constraints that phones put on you, which I think is an interesting discussion to have that we can have after this if you want. But basically, one of your constraints is like, okay, you don't want to use a lot of battery power, processing costs power, so, what do you do with an app when it's not showing? And this is kind of how Android deals with that. And I won't go through like QA because it's just reading. But basically, onCreate is your starting point. So when your app's created, that's what happens. And actually, it'll probably just be easier and more beneficial if we go through here. So this is the Android lifecycle. And this like confusing chart, which we'll go through step by step, is part of the intricacies of Android. So because there's no main method, and because your app can be started and stopped, and paused and hidden, and all number of like horrible things to deal with usually, you have these number of callbacks that you have to deal with. So when your app first starts, so when you click your like wonderful Facebook app, the first thing that happens is onCreate. So that's the first callback. Now onCreate is like the birth of your app. That's when you have like, that's your chance to like set everything up, set like your state up, whatever you need to do.
Set the view.
Yeah, set all the views. This isn't, you note that your app's not visible at this point, so you can do whatever you need to the UI to like update it or draw it. You don't, not that you have to handle like drawing on your own, but like whatever you need to dynamically do, this is the place to do it. From there, we call on start. It's visible but not active yet, so users can't quite interact with this. Truthfully, not 100% what really goes in here. I think I saw like something about broadcast receivers, different callbacks, different UI stuff, but for the most part, your main code is going to go in your on resume. So now the on resume callback is like, all right, your app is like started, it's visible, the user's using it. This is like the main logic of your app should probably go in this section, or at least start in this section. And I'll go over another reason why. So you'll also notice that the chart kind of loops back on itself. So this is another reason. So on resume, after your UI is all set up, this is where you handle things like what to do in the background while the user is like doing its user thing. It's like, do you need to like update like data in the back, or do you need to maintain some kind of state? On resume is a good place to do that. On pause is you're partially hidden. So like, if you've ever seen like, say you're using the Facebook chat app and you have like a Facebook head like chat open while you're using another app, your app's obstructed and no longer taking input. So like it's partially visible, it's still kind of doing stuff, but like it's not interactive with the user. The important part to note here is that this is the last place that your app can't be killed. I'll go over what that means in like a second. So you should save like some of your state here. So if you have like user information that they put in, so like, I don't know, if you're doing like a Word document, let's say, this is where you should probably save your Word document if you haven't already. Or like this is where you should probably close your file objects and save them if you haven't done that. Which brings us to on hidden. Did that show? Okay, so on hidden over here, this is when you click like the home button. So now your app's in the background. It's not doing anything. It's completely stopped. And from this point, Android can kill it. So what that means is that at any line of code on the onStop method, Android could be like, well, your app's done. Like, you can be halfway through the method, like line 24, you have like 40 more lines, doesn't matter. Your app can be killed. And this is important to note because you can lose, if you haven't saved your state and on pause, you may never be able to. So users kind of hate when you lose their information. So that's something to keep in mind. So on create, on start, and on resume, and on pause are 4 places where you're safe to do any code from start to complete. On stop and on destroy, it's kind of up to Android. So one of the other constraints is that Android phones, or like phones in general, not as much memory, not as much processing power. If if your app starts to become a memory hog, Android will kill it. If your app does anything slightly bad, Android will literally murder it. So that's one of the things you also have to use too with Android. This idea of callbacks where like your app goes through lots of different states. And then from there, you can either go from stopped to started on resume, so you can call on start again. You just go through the cycle. Or you can either go on to on destroy. On destroy is like your app is completely done. Like there's no coming back from that. That's when the user like press the X button on a desktop app. So at any point, if you haven't done anything that you needed to, like release some streams or like share data, this is like kind of where you have to do it. And you can call this yourself by calling finish. There's a finish method you can call. And basically that's like, okay, I'm done. It's like a system.exit for those who, yeah.
We're trying to run like some background processes.
So background processes are a little bit different.
Called
There's,
services.
yeah, they're called services. Okay, who else? This is probably another thing. They're also run on like background threads. So like threads are handled a little bit separately. For anybody who doesn't know what threads are, parallel computing. Does anyone not know what threads are? Okay, a little bit. That's okay. We'll go over like what it means to like be able to do multiple execution paths at the same time. If you don't know what multi-threading is, we'll like go over that. But for that kind of stuff, Android can handle it a little bit differently. For things that like run in the background, so like you can make apps that don't have like a UI. So say you just want to like query Twitter, then finally, this is where we like make our hello world. So there's two ways of kind of organizing your app. We're gonna go over both. The first way is activities. So like I said, Android can have an activity, and I also mentioned that because Android doesn't have a main activity, like doesn't have a main method, your app can actually be started from like multiple activities. So you can have an activity dedicated to like opening or like displaying a contact list, let's say. Or you can have one like you can have a main activity like that's the first part of your program.
Almost like a homepage on like a web page.
Yeah, exactly. So like from there you can kind of navigate through these activities, and they're kind of like self-contained programs. This kind of gives you, and like this makes Android a little bit unique. I don't know how it works on iOS, but this means that you can make your activities like known to all of Android. So let's say like, and this is an example for something I did. Let's say that you need to scan a barcode. Well, someone's obviously done that before. Why write the code to do that again? I can send what's called an intent to like this activity, like, hey, I want you to scan a barcode for me and send me the result back. Using the intent system, which is basically a way of interacting with Android as like a whole. So like your app is like a small part of Android, and then like Android has lots of other apps. So you can actually like interact with each of these. Now, part of that, it's like part of the useful part. So maybe you've noticed like when you click the share button, like multiple activities pop up, like multiple apps, right? So that's because you can broadcast like your app to all of Android, and you can kind of utilize that. So I guess I'll like draw something on the board. So one way of writing Android UI apps, like a UI, is that you have this like main activity. I don't know. I'm just gonna say anything. Sorry, people on YouTube. So here's like your main activity. Now when you go to an app, we have what's called like the card stack. So when you go to a new activity, so you launch one using an intent, it basically puts this activity in the background, and then on top of this, so like as a stack, let's say like this is the bottom of the stack, we then have like our next activity. So let's say this is like contact list. And then let's say that we click on like a contact. It then adds like your contact information. So like here's Joe. Now note that these are all hidden. Now when you click the back button, so like for those, hopefully everyone's interacted with an Android phone. When you click the back button, basically it just goes through this back stack. So
Sure destroys. It calls not destroy.
oh, yeah. So like when you call back on this, it's probably going to go through like, so each of these has its own activity lifecycle. So like once you send an intent to this guy, it gets called to like onCreate, and then it goes through that entire lifecycle. Once you click back and you're done with that, it calls onDestroy, and then it goes back to here, and it kind of unravels it. So this is called the card stack method of like writing apps. This is useful for phone, like regular phones, right? Because you really only have a limited screen space. So how do you display all of this information on one device? And Android's like solution to that is, okay, we'll self-contain each of these components. So A, they're reusable, which is awesome. We like reusing code. And B, we'll basically just have them take up the entire screen. So because of this card stack, it gives users a nice way of navigating, because ideally when you click the back button, you should just unravel what you did. Which, best practice, if you're writing apps, you should make it consistent, so the back button should always take you back. It shouldn't go somewhere weird. Like, you should never skip from this to this. It's probably bad for users. And that's all on the Android website. Any questions like card stack? Now, there's another method of writing like views. So when tablets came out, you have a lot more screen real estate, right? So like, do we really need our main splash screen to take up the entire tablet when we can clearly like have both the contact list and like the person information? Android's like solution to that is we'll have this thing called a fragment, and we'll go over what fragments mean next workshop. I think probably is a good idea because they're a little bit more involved. Basically, fragments are they took these activities, they shrunk them down into like littler pieces, so you can't have multiple activities inside of each other. So like activities are self-contained. They're like an entire part of your screen. You can have what's called a fragment. like this is your phone. And now you have like fragment, probably do this as a tablet layout. So now you have your contact list over here. And you have like your person, this is Joe, he gets more room, over here. So today is just like going over like this method. As you're developing, you probably want to do, you'll need to probably do both. So when you have more screen real estate to deal with, this is another part of like what kind of constraints mobile brings to like the table. So on like a desktop app, you don't really care about any of this, right? You have like a window, it's resizable. Like usually that's kind of like the user's problem if their screen's too small. You can at least guarantee it's like probably a 12-inch screen. On mobile, like what do you do with someone who has like a 14-inch screen or someone who has like a 2-inch screen? So this is kind of how you have to think. So today, like I said, activities is kind of what you want to focus on now, and then we'll go over fragments after. Any questions on that? Yes?
I have a question about intents.
Sure.
You said like a whole talk list that you can figure out.
So basically intent, actually I think it's on here. So you have this thing called the Android manifest, which is the next thing I guess I'll get into. It's on here. And the Android manifest is like, because your app exists in like this ecosystem on the phone of apps. Oh. So because like I said, your app exists on like this phone, and you kind of want users to be able to interact with other apps. Like you don't want to redo something when a user has like an email app. Like they probably like using that email app. There's no reason not to like use that. So we have what's called like intent filters, I want to say it is. Or like intent or content filters. And basically you can send an intent to Android like, hey, I want to open up a mail app. And Android will then handle that. If you're dealing with your own apps, you give it the class that you want to open. And it actually might be in here. No, it's not. But I can go through like a live coding example of that next. Basically, you give like the intent, like it's just a class. So you instantiate your intent. You're like, okay, I want to open up like the contact list class. So you just give it like the class name itself, and then Android kind of figures this out based on your manifest. Now, every activity needs to be declared inside the manifest. So if you compile your app, you run it on your phone, you send an intent, you're like, okay, I want to launch my contact list activity. If you haven't declared it in the Android manifest, it's going to go into the OS, the intent like trickles up and Android does some magic with it. And Android goes, okay, where is this class? And it looks for like your, it looks in your manifest, it says, I don't see that class. I have no idea where that is or where it exists. And then it crashes. Crashes are bad, right? We hate when our apps crash.
Can I talk about the manifest?
Yeah, go for it.
Alright, so the way I've always thought about the manifest is it's like a blueprint for your entire app. It defines all of your activities, all of your services, all of the permissions that you may need. Even like the name, the icon that you have on the,
Yeah.
like the
Actually, I can
icon
like,
that
show
you
it.
have, everything that you want goes in there. It's just the OS's way of seeing what kind of stuff.
And I'll watch Studio now to show some of this. So one of the good and bad things that Android gives you is because of this, there's a lot that you kind of have to get into to do Android. So like now you need to not only know how like the activity lifecycle, but now you need to know what what the Android manifest is, what are intents, etc. But it gives you some it gives you some interesting power. So now you can launch other activities, like you can launch other apps to do your work for you. So if you need to like make an app that say posts to Twitter, why write code to post to Twitter when the user might have a Twitter app? So now you just say, okay, I want Twitter to open. And then you send an intent, and Android just pulls that app up. If they don't have it, it just sends them to like the Play Store or like not supported type deal. So this takes a lot of burden off of you, and also gives you a lot of tools. So like, once again, going back to example, I wanted to write like an app that like scanned a barcode. I have no idea how to do that. And the last thing I wanted to do was read up how do I like do like character and like optical recognition and do like camera stuff. Whereas Android just kind of found an app and that app did all the legwork for me. So this kind of gives you a lot of tools to work with and also makes your life a little bit easier. So now, I guess going from there, exit out of this. So this is the actual Android manifest. Here I have two activities, activity main and activity main 2. Probably not the best thing to name them each. They're just examples. In my manifest, you'll notice that first off, it's also XML. So all of the resource files that Android uses, so all of its layouts, the manifest, I guess that's actually it, are saved in XML file format. So it shouldn't be too bad, like going from one resource to the next. So here's my main activity. Notice we have an intent filter. This tells Android like the actual like above your app. Okay, I can like these are the intents I can respond to. And Android has some defined for you, so like they probably have some global ones for like mail apps or like a messenger app or something, stuff like that. Those you can find in the documentation. But you'll also notice that this activity main, not activity main, activity 2, has this intent filter with android.intent.action.main. This tells Android when a user clicks your app, this is the activity that should load first. So because you don't have a main method, you still need to have some like starting point, right? Like as a programmer, you need some sanity as like, where is my program going to at least launch from?
Yeah.
So you can set up your state and like set up anything you need to do.
I think you also need a dot launcher method.
Yes.
Like,
What does that do?
I'm pretty sure both the dot main and the dot launcher need to be there to launch your app, but like you can change it to dot default, which is like for every other activity.
Yeah, I'm not actually 100% sure what the category one does. So Android, so when you create a new activity in Android, it generates this for you. These two I do know for a fact you need for main.
Does that have anything to do with the activities model or activity models
That probably not. I'm not 100% sure. This comes to the other like problem in Android. They add a lot and they deprecate a lot of stuff, and working with it can be a nightmare when you're trying to remember what SDK stuff's in. But luckily, Android has really nice documentation. Actually, I'd say it's probably one of the best documented stuff I've seen.
All of Google's stuff is very well documented.
Yeah.
I've
So
ever worked with anything.
the nice thing about that is that in the Android documentation, I haven't found a class that hasn't done this. They basically give you a code snippet of how to actually do the common like stuff in it, which is very nice. And now notice here for my other activity, activity main underscore activity 2, I have it. I give Android the name, so I declared it in my manifest so I can actually launch it. Notice that I use this. It generated this like dot main activity 2. It can kind of find out based on the relative path of your Android project that you don't have to include the fully qualified name. So like, I think the fully qualified name would be like com.example.geno.myapplication.mainActivity2. So this is how I'm like pulling that name out. You can just put dot main activity 2 and it'll usually find it for you. So going from there, let's like just launch this app because that's probably more interesting to see. I'm gonna launch this on AVD8 so everyone can see in case I don't feel like plugging my phone in.
There's no way to show it.
Yeah, there's no way of showing it. Anyone have really questions so far? I will apologize. Like, I was assuming that everyone would be able to download everything a little bit easier. I probably shouldn't bet on UB's like any infrastructure. So it didn't find any phones running, so I chose to launch it on the AVD instead. Hopefully it'll go like to.
It's ridiculously slow.
Yeah, they've made improvements. They have actually. Like, I surprisingly can run 5 of these. For anyone who knows, like, we have a distributed class, which is basically like, it kind of teaches you how to write programs that work on multiple like network systems. And the fun part about that, or the not so fun part, is that they chose to do that in Android, and we need 5 Android like AVDs running at once. Luckily, I have like an i7, and those who don't aren't doing so great with running these things. So this is a full like virtual device. It's actually kind of cool. I found out you can actually browse the internet with this thing. I don't know why you would, but you can. So you should see like, hey, the thing that they showed on. So we go back to our like layout file. So it'll like show you a mock-up. So it generates this like image So next thing we'll do is like I'll just show you like how to go through editing the layout. We'll add a button and we'll like launch an activity. So to do that, I should probably mirror my screen if I have to type looking at that. No, I put the wrong button. I'm sorry, I don't know how to computer. It's all new. I'm actually a freshman. I'm just like lying to all of you.
He's just making this all up.
Alright. So first thing, like I said, I'm just gonna show like how to edit the layout via XML because I think it's the best way to do it personally.
Unfortunately, I can't tolerate that, but it's
I
my
can
blessing.
totally make it bigger probably. Okay. Probably, maybe. Oh, please. Oh wait, what is this? This is a presentation mode. Okay,
Wow,
cool.
that's awesome.
So basically, first off, every Android layout has to have like a top view group. So remember when I said the view group pulls views? Android needs something to put all the views in. There's a couple different layouts. Relative layout kind of lets you position everything by like coordinates if you want it, or like relative to other elements. Linear layouts are a little bit easier in my opinion. So a linear layout, I'll show like a nice mock-up example. Sorry guys. So if here's our phone, if our linear layout lays everything out either by vertical or horizontal axis. So if I put one linear layout here, so like, and I do that vertically, it'll align everything down. So then I can put multiple linear layouts inside of it, let's say L2, to be horizontal. And this is kind of an easy way of building your UI. So if you kind of compartmentalize it and then like mix in these layouts, it's Android does all the resizing for you, which is really nice. And B, it kind of gives your app a nice organized feel, as well as not being a nightmare to look at in the resource file.
Having worked with relative layouts, they are really messy. When you move one small component, it can move everything.
Yeah, and although as a note, you will suffer. So you will suffer some performance loss if you like start embedding 10 layouts inside of it. So every time you have a layout, Android does some fancy like calculations on the views to figure out how to like place everything. And as you go deeper and deeper with view groups, you will start to have a performance loss. If you get like 3 levels in or 4 levels in, and you're like, all right, I have a linear layout and a linear layout with a relative layout and like some grid layout, you might want to consider like moving some of those view groups elsewhere, or like moving it into another activity or fragment, just as like a best practice list. So I'm just gonna change this to linear layout here. This tells the Android, yeah. So for those who worked with HTML, you'll notice that you have these tags that you need to open and close. Just like HTML, inside the opening like tag, you actually have like properties you can give it. XMLNS tells it which XML namespace it's a part of. So you're using the Android namespace, this lets it autocomplete for you. And this tells you like which tools to use. For the most part, Android will generate this for you. You don't really have to memorize it. And then we have a lot of other stuff, which I'm going to get rid of because it's not too great. Let's see it. Which one do we need? Okay. So one thing we do need, you'll notice that because we gave it the namespace, it autocompletes, which is really nice, is that we need to tell it the width of the width and height. So you'll notice it says required. We're just going to have it match the parent. So basically we're going to make this the entire screen size. Like match parent. We also need to give it the layout height. And once again, we'll just go match parent. You can make this relative, so like Android will do some calculations and wrap your content for you. Usually your top view group, you kind of like want to be the entire screen size of it.
Wrapper.
Yeah, so like basically, usually like your top one is going to go like the entire screen.
Does this like automatically build?
it says like match parent on the full screen, go back to your phone example. And Zach, correct me if I'm wrong. You have like your action bar, and, like your name, like title. And the top view group, like the parent's the phone screen size, it's going to make that this guy. So like this is your layout. So like this is our top one, right?
Yeah.
Okay. When you go into full screen, it'll automatically take that into account. So like there is a full screen mode, and it'll like redraw your layouts. I'm not actually sure on the process of that, but oh, I have like a chart. Good question though. So once again, like this kind of comes in the deal with like fragmentation. Like the action bar is kind of new, once again relatively, and these are all kind of things you have to account for. For the most part, Android takes care of a lot of this, which is nice. And you can, I know that there's more information on like full screen apps and stuff like that. Alright, so this is just kind of, I'm going to get rid of the text view. So now I kind of want to design my app so that like, we have like our linear layout here. Like this is linear layout. And I'll make it horizontal, and I just want like a text field and like a button. I don't know, okay. And then on my other activity that I want to launch, so this is like launching from one to the other. I just want to take that and display it in like a text view. So like whatever we put here, like below, I want to appear like below on the side. So this is kind of how I'm going to drive my like design of the app. So first thing I'm going to need is the ability to like enter text like somewhere. Android has an object for that called edit text, and we're just going to make the width that's the parent for now, and we'll wrap the content. Now wrap content just says, okay, make it as big as you need to be, but no more. And then, actually we'll do wrap content here too, so we can get everything in the same axis. Now because I want things to like kind of lay out horizontally, I'm going to, let's see, do you remember the command for vertical?
Return center.
No, like to go on the x-axis. I don't remember. Okay, that's fine. We'll just keep it like it is. Hold on, actually, vertical. Always the problem with live coding demos. Alright, we'll just keep it regular. I don't want to like put something wrong in. And we'll also have like a button. And we'll just make that wrap content, and we'll just match the parent, or we'll also like wrap the content here. Yeah, so now I'll set the text to something. There's a lot of different ways that you can set the text. Best practice for Android is that there's a resource file that holds all of your strings. I'm gonna, because I just want to avoid that for now, I'm just gonna hard code the text in.
It actually kind of, it'll sometimes yell at you if you don't use the resource strings.
Yeah, so like, so the whole idea of it is that you don't want to have all of your strings in different places. You want to try to reuse as much code as possible. It makes your life way easier when you're like changing UIs, or if you're building different UIs for different like screen sizes. So this is kind of why that's bad. But just for the sake of today, we'll leave like that. And I'll also put like a hint in here. And we'll just say type something.
And all that hint will do is like you're on Twitter and you like want to enter in like something for search.
two ways of now interacting with these components. So now you need to respond to like what happens when you click the button. To deal with that, so like we have like a process now. So here's our UI code. We now need our logic code. Like we want when someone clicks the button, we need to grab the text from the edit text field and go send a new intent. So to do that, we need to be able to access this edit text. So we need to give it some ID. And we'll like go text field here.
And it's just the notation that it uses at ID slash.
Yeah.
It's like that string.
So this symbol here says like this is where you can find that resource. So it like dynamically links everything for you. It says plus ID because I haven't yet defined a text field in the ID file. So like the ID file is just like a resource XML file that says, all right, like here are all my IDs. I haven't defined one, so I can just like I can define it here, and it'll add it to it. It'll add it to the file for me. And that's pretty useful because if you're going to be just using it like a once-off thing, this is kind of like naming your variables, like temp variables. There's really no point to like naming a global variable that you only use in one place, right? Now, the next thing we need to do, and for those who use like Action Listener, once again like most of you, is we need to respond to the onClick on some way. And to do that, we have a couple ways of doing that. I'm going to show you like doing it through XML. I can also show doing it through like programming. But we can define like a method here, or like we can define the method name to use. So let's call this example, probably one. So now when we click this button, it's going to look for the example method. So now, if I can go to exit presentation mode, go into my code now. Inside of my code of main activity, because that's the one we just wrote for, you'll notice that Android kind of does some legwork for you when you create it. It automatically overrides the onCreate, so you need to at least override the onCreate, otherwise your app doesn't really do much. I think it's also abstract anyways. So it sets the content view to be your layout. The thing also worth noting is this R. So Android, once again, because like it's kind of a weird system, and not to go too much into it, has this auto-generated class called R, which as you type and save and build your stuff, it kind of compiles all of your resource data. So like that edit text field I just made, or like that layout file, is in this R class, or R object, R class. It's a class. And it sets the content view to be like that layout. Now we need to, once again, handle like the onClick command. To do that, we need to have a public void example, because that's what I called it, and it needs to take in a view v. V is going to be the view that was clicked, so you can like view something to it. And we need to make sure we import it. So just to show you once again, it's just Java code. We still use like imports and like packages, just a regular class. Now whenever the button's called, it's going to call like this. So now we need to actually grab that string that we typed into the edit text field. So we'll call it this. And here comes like another like Android thing. We need to pull the text view, or like not the text view, the edit text from that like resource. Because what Android does when it first creates your app, so going back up here, when you do set content view, it goes through your XML and it looks at everything you wrote and instantiates all of those classes. So like it basically creates those objects outside, like inside your code for you. So now we need to get a reference to those objects. To do that, we can use the ID and we can go to text field. Now it's going to yell at you because it's going to return, I think, just a view. Yeah. So because all of your views, no matter what class they are stored as like views in this find view by ID. Like, it doesn't know which view it is. It might even be a view that you made yourself. You have to cast it, and hopefully casting isn't too bad. saw that the same edit text that we had in XML is actually just a type. So this is an actual class that exists in Android. So the other nice thing that the XML does for you is that it goes through and it builds all your objects for you. Now we need to actually get like the string out of it, which is what we'll do here. So you can call it get text, and then we have to get the toString. And this basically just pulls the string out of the text. We should also probably set the text to nothing. So like now it's blank again, so when users come back, they don't have too much trouble. And now we need to start our new class, or our new activity. So we want to go from this activity to the other one. To do that, we make an intent. So say intent I. Which one is it? And your intent needs to take a context and a class name. Now, this is a good place to talk about context. Notice that we have main activity extends activity. The activity class itself extends context. So every activity is a context. And the context kind of gives you a handle to the operating system as like a global thing. So because you have all of these activities, right, but they're all like part of your single app, you need to it basically allows you to access other parts of your app. And it also allows you to access like Android components. So say you need to like get a system manager, or like, what's a common one? Or say you want to like register like a GPS listener. You have to do that through Android. Context gives you a way of doing it. So you never have to like implement a context yourself. The activity, like Android kind of does that for you. So we'll give it, once again, since every activity is itself a context, we give it this. And then we need to give it the class of the activity we want to start. And that notation might be a little bit weird, but this gives you, that like gives it the class context deal. From there, the next thing we need to do is how do we get the string from edit text to that activity? So if we go back up here, you might notice that we have this thing. So everything started through an intent, and because they're separate, we don't have the same like resources. So from that, we can't get the same components. So what we can do is bundle some data with the intent, and hopefully I remember how to do this. Here we go. So let's just put a string character sequence. Put extra. Here we go. Now we have to call it something, so like we need to actually like be able to reference this, and I promise this will make more sense when I get to the other activity files. Let's just call this edit text. As a note, you should probably make this a static public variable. Actually, I'm going to do that because it will probably make more sense. So up here, I'm going to define this public static string. Let's do. And now in our main activity 2, we'll be able to like access that key basically. It's just a way of reducing code smell. I really hate live coding. Like being in an interview all over again. But I don't get a job out of it. And we have to actually put the string. So now what we did is this intent like object. We've put basically, hopefully, who here doesn't know what a hash map is? Alright, great. So the intent can kind of act like a hash map where we can store key value pairs. So when we send this to our other activity, we can pull those key value pairs out. And then finally, we call start activity. This is basically the same notation as this dot start activity. This comes from like the context object that I said earlier, which is like a superclass of the activity. And when we call this line, we'll launch into this activity. Now to kind of like show you a little bit different, instead of building the layout through like XML, we're gonna use the set content view, which basically like sets the screen up, and we're gonna use that to like build our UI by programming. So a text view is what basically holds text and shows it. So like that's the hello world we saw earlier. And now we can see like instead of building it through XML, we can actually define this like on the actual onCreate. So there's two ways of doing this, just to like expose you to both. And then finally, we need to set the text of that. Sure.
Since you did it in XML, where are you supposed to override?
So when you call set content,